All right, so this is the second lesson on surface area for our Math 10-3, and it starts off with a little bit of review. I'm not gonna go through all the work of this one. If you need some extra practice on this one, I'd recommend going back to the last video. Um, but I will just say that what we're doing here is we're finding surface area, right, which is the space inside of a 2D object. Okay, so we're not talking about like how much can like a 3D object hold. We're talking about just like the flat surface area on a 2D shape here. Okay, so in this case, it's like it's saying how much space or how much space is inside of this shape. Okay, if we were to color all of this in, or if you were to think of it of like if each one of these is a meter, um, this would be like a meter squared, a meter squared, a meter squared, and we would talk about how many of those little boxes would fit inside here. Okay, so that's what we're doing when we're finding surface area. So whenever we have these weird shapes like this, we would break it up into shapes that we have an equation for. Okay, so we could say I'm going to break this up into a rectangle here and a rectangle here. And now we have three rectangles and this problem becomes a lot simpler. Okay, there is no formula sheet or no formula on your formula sheet for what to do with a giant C-shaped object. Okay, you're not going to find that there. Sorry, excuse my zooming issues here. Okay, there we go. So you would just say, I'm going to find the area of this shape here. So I could just call that like rectangle 1, and I could find the area of this shape here, and I could find the area of this shape here. And then once I found those three, I would just add them together. Area of 1 plus the area of my second shape plus the area of my third shape plus the area of my third shape all together would give me the area of the whole thing. Okay, of my weird C-shaped whatever. These are all just length times width things, right? This one would be 3 times 7. Okay, this one you might need to, it'd be 12 times however long this distance is. You need to figure that out by saying like 12 minus 7 and so on. Okay, so if that part's not making sense, I would recommend going back and watching the last video. This one here is this part simpler. We only got two shapes here. We got a rectangle here. I'll call that my first shape. And then our second shape is half of a circle. Okay, so on our formula sheet, there's an equation for a whole circle, but there is not an equation for a half circle. So all we would do is we take our equation for a full circle, which is pi r squared, pi times the radius squared, and divide it by 2. That would give us the area of half of a circle, right? Take the whole thing and just divide it in half, give us half a circle. So the area of shape 1 here would be our length times width. So this one is just like 20 times 30 would give us the area inside here. And this one is pi times our radius. Remember, our radius is just half of this distance, right? The diameter is all the way across, so the radius wouldn't be 20, it would be 10. And then we need to square that. Okay, so we would take this area, add it to this area, and that would give us the area of the whole thing. Okay, so there's our review. And let's get on to finding the surface area of now a 3D object. Okay, so the first thing that this kind of talks about is nets. Okay, so not like a fishing net, but a net is when you take a 3D object and it's basically like unfolding that 3D object into a flat surface. And then it becomes a lot simpler to see kind of what the surface area is that you need to find there. Okay, so if you think about this being like a piece of paper that you could fold along these lines, then this would fold up. Okay, so that these two triangles would fold up and it would kind of wrap around here and you would end up with a triangular prism. And so let's see if I can actually draw this here. You'd end up kind of with like a triangle on one side and those three rectangles would end up folding. Okay, and I'm going to draw dotted lines here to show that these are behind. Okay, and then you've got a triangle on the other end. Okay, so you'd end up with like this this prism shape here. So to give a example that I don't have to draw, actually here, let's look at this one quick. This one is a bit easier to see what it would fold into. This one would fold into a cube. It has these little extra tabs here. This would be like if you were actually cutting this out on paper, these extra tabs would just be for gluing, you know, to the inside. So we wouldn't actually count that as far as our surface area. But this is how you can kind of calculate that or like visually see the surface area of a 3D object. So if you think of like just an ordinary box, okay, a little blurry. Okay, if you think of like an ordinary box that you might get from your, grocery store, whatever. When we're talking about the net, okay, this is what it would be when it's totally folded up like normal, assuming that tab's down. Okay, if we're talking about the net, this would be when we unfold it, it will show us kind of like the surface area of the entire outside. So if I was trying to figure out how much area is around all the outside of the box, okay, not talking about the inside of the box and not talking about how much things it can hold, just how much space is around the edge. Okay, if we were to unfold this box, then we would get one of these nets essentially. Okay, we do not care about the inside of the box. We would only care about the outside. So that's what we mean when we say a net. If it ever asks you to draw a net, it's basically telling you to take this 3D shape and unfold it into a flat surface. All right, so when we talk about the surface area, right, we're talking about that outside area. So let's now take this example of a box and talk about what are all the shapes around the outside. So let me just flip over here. Okay, so this example is talking about if we wanted to find the surface area, we need to find out what are all the shapes that go around the edge of this box. So I'm not going to try and draw unfolding it here. I'm just going to draw what are all the shapes. So what we have is we have this rectangle here that's like 11 by 6. We have this rectangle on the end, which is 5 by 6, right? 5 times 6 for the area of that one. And then we have this rectangle on top. This one is 11 this way, and it is 5 across this way. We can kind of tell by this 5 down here that this is 5 across. But that's not all, okay? Because we're not being shown that behind this there is, right, all these backsides and underneaths that we can't see. Okay, so what we get is that there's another one of this front shape is going to be the exact same on the back, right? There's another one of this front shape here, right on the backside. And there's another one of these shape 2s on the other end over here. And we have, lastly, the top, which is shape 3, is going to be the exact same as the bottom. So really we have like the front and back, we have like 2 of these shape 1s. Okay, shape 1 I had is the front, but we also have the back of the object. Shape 2 was the side, and we also have the other side. So we've got 2 of those. And then shape 3 was the top, and we also have the bottom. So we've got 2 of those. So all you really need to do here is find the area of these 3 shapes and then just double them. And that will give you the surface area of all 6 sides. So if I were to draw them out, a shape 1, I said was the front, and it was 11 centimeters by 6 centimeters. Okay, it was 11 centimeters by 6 tall. Tell that's 6 tall. Then we have shape 2 was the sides. So that one was 5 by 6. I'm going to draw it flat here. It was 5 by 6. And then we have shape 3, which was the top. Okay, so the top was also 11 long, and it was 5 across there. All right, so we've got the front, we've got the sides, we've got the top. And so if we find the area of these things, we just need to make sure that we times them by 2. Okay, I'm not going to take the time to, I guess I could draw without the measurements. Okay, we've got the top and the bottom, the side and the other side. And then lastly, we have the, front and back, side and side, and this is top and bottom. Okay, excuse the ugly rectangle. So on your formula sheet, it tells you an equation for how to find the surface area of this, but it's really just doing all of this. It's just taking all of this and putting it into one big equation. Okay, so let me show you what I mean here. On your formula sheet, on the bottom of the second page, it has an equation for the rectangular prism. So it tells us this big equation will give you the surface area of the entire thing. This is just saying 2 times the length times the width. Okay, this is the area of this bottom shape here, and it's giving us 2 of those. This is the area, width times height, of the side, and we have 2 sides. Then we have 2 times the length times the height. The length times the height is the front, and times 2 would give us the back. Okay, so this is just putting all into one big equation, what we just did kind of by hand, figuring it out. If you would rather do it this way, you may, right? If you can figure out what's the length, what's the width, what's the height, you can put it all in like this, but you need to be very careful that you put it into your calculator exactly this way, okay? 2 bracket times the length times the width plus 2 bracket. Okay, you can, yeah, you could do 2 times the length times the width without the brackets, I suppose. This mostly just makes it more clear. Okay, it will still give you the right answer if you do it this way. It just makes it a bit more clear that we're saying like this is the area of one of those shapes and we're doubling it. So grouping these just kind of helps us understand what it's talking about. The other way we could do it is by kind of doing it manually by hand, where we just figure out what's the area of those 3 shapes and add them all together, and don't do it all at once. Either way is fine. So I'm going to do it kind of the hard way, but you're free to show your work however you like on your assignment here. So the area of shape 1, okay, that was our front face here. We said was 11 by 6, so we would say 11. The area of shape 1 was 11 times 6. And I'm going to times it by 2 to also give me the front and the back. Okay, or I guess I could just say that this is 66, right? Centimeters squared. But I have 2 of those. Okay. The second one is the sides, and they're 5 by 6. Okay, the sides was 5 by 6. So that's going to give me 30 centimeters squared is how big just one of the sides is. And then the top is 11 by 5. So the area of the top is 11 times 5 is 55 centimeters squared. Now if I want to find out the area of the entire thing, okay, I'm going to need to add these together, and I'm going to need 2 of each of these. Right, so it'd be like 66 plus another 66, okay, for the front and the back, and then plus 30 plus 30. That's the 2 sides, and then I'm just gonna, okay, I'm just gonna kind of wrap around here to say also plus 55, just because I'm a little bit out of space, and plus another 55. That is the top and the bottom. All of those together will give me the final answer. Right, so adding those all together, all 6 of those sides gives me 302. And remember that our units are centimeters squared here. Okay, and that would be our final answer. So we could have put this all into that big equation. This is kind of just a more, this way is a little bit easier to understand what it is that we're actually doing. All right, so then it brings us to this next example here. Okay, this one's not quite as symmetrical, so it does take a little bit more thinking about what these different sides are. So we have this triangle shape, okay, that we'll need to find the area of. I'm going to call that area side 1, okay? And you'll notice that the triangle on the other side is going to be the exact same. So we have 2 of these shape 1s. So I'm going to call shape 1, we say we got 2 of those. And that is our triangle shape here. Then we have the bottom. Okay, so I'm just going to draw 2, excuse me, 2. To draw an arrow to try and show that that's underneath. Okay, shape 2 is the underneath, and we only have 1 of these. This one is 4 by 11. Okay, it's 4 kind of wide and 11 long. So that's this rectangle. That is, I'm going to call, maybe I'll draw it this way so it's a bit more clear. That one is 4 by 11. Shape 3, I'm going to say is this backside here. Draw this. I'm just going to draw an arrow just to make it a little bit more clear. Talk about that backside. It is 3 by, this side is 11 long. Okay, we get the length from this side here. This 5 centimeters is talking about this length here, so we don't want that. All right, so shape 3 is that backside. Okay, and that one was 3 by 11. And then our very last one is this top. Okay, it's this shape right here. That one is 5 by 11. So I'm going to call that one shape 4. And draw it something like that. You don't need to draw them at angles like this. I just tried to make it a little bit more clear of which one I'm drawing here. 5 times 11. Okay, so these are all the shapes I need to draw. I guess I'll show that this one, the measurements here that we care about is that it's 3 for its height and 4 for its base. So we've got 2 of these triangles, 1 of this rectangle, 1 of that rectangle, 1 of this rectangle. To find our answer, to determine the surface area, we need to find the area of each one of these and then add them up. Okay, this one would be like 3 times 4, which is our base times height, and then divide by 2. This one is just 4 times 11. This one is 3 times 11. And this one is 5 times 11. Length times width, length times width, length times width. And then remember that we have 2 of these triangles. So we would need to, this one ends up giving us like 6. And we're talking about centimeters squared here. Maybe I'll do that in blue so it's a little clearer. This one gives us 6 centimeters squared. So we have 2 of those, remember. Okay, so we have, we need to add this one twice, another 6 centimeters in here. So if we say 6 plus these 3 areas, that will give us our final surface area altogether. All right, so what I did here is I just added those all up. 6 for the 6 plus 6 is the 2 triangles, 44 for one of the sides, 33 was one of the sides, and 55 was one of the other sides. Altogether, it gave us 144. And remember that we were working in centimeters, so this is going to be centimeters squared. All right, so for the last 2 examples, now we're given kind of weirder shapes. Okay, these ones have a formula on your formula sheet as well. So on your formula sheet, it tells you, remember that this SA is talking about surface area. Okay, we're not talking about volume here. So this is giving you this plus this is going to give you the total surface area. Okay, you'll notice that this is pi r squared is the equation for the area of a circle. Okay. The area of a circle is pi r squared. Here it has 2 pi r squared. What this is talking about is it's talking about the area of the top circle, and it's talking about the area of the bottom circle here. Okay, so we've got 2 circles, and that's where this is coming from for this equation. This section here, 2 pi r times h, that's giving us the area of the everything else around the outside. Okay, that's like this part of the cylinder, everything else other than the top and the bottom. And this is actually just a base times height equation. It's just kind of like talking about if you had a piece of paper rolled up. You got a piece of paper. Okay, so it's easy enough to think of the area of this piece of paper would be just like our length times width. It's less clear when we're talking about like the edge of a cylinder. Excuse me. If I rolled this up into a circle, okay, it's not as clear about how you would find the surface area. It's still going to be the same. It's still the same as this paper here. It's a rectangle. But when I roll it up, you need to figure out, how do I find what this edge is and this edge is? Well, the height is easy because the height stays the same. It hasn't been changed at all by being rolled up. If it's rolled up, though, the way you would find this length of this edge is you use the circumference of a circle. What's the length of the edge of that circle? Okay, and that's where the equation comes in, which is 2 pi r. Okay, 2 pi r tells us the length of the edge of this circle, so that when we unfold it, now we're just saying this length is 2 pi r, and this side is our normal height, and that will give us, our width times our length times width. All right, so this video is getting long, so I'm going to try and speed it up here. Okay, so 2 circles, outside edge. This is really just a complex way of saying length times width. All right, so we're just going to use that equation. Okay, so the equation for the surface area, you're just going to copy it off your formula sheet. It was 2 pi r squared, gives us the top and bottom. Okay, that's this circle and this circle. Then plus 2 pi r h. Okay, this is the length of the edge, and this is how high it is. And then we just plug in our values of r and h. Okay, so it becomes 2 pi r, which is 5 here. Radius is 5 squared. I'm just showing this brackets is showing I'm multiplying 2 times pi times 5 squared plus 2 times pi times our radius again is 5 here, and our height of the cylinder is 10. Okay, so you're going to punch this all into your calculator, and it will give you your final answer for your surface area. Okay, this was giving us the 2 tops and the outside of the cylinder. All right, so you get a final answer then if you put this all in right. And I would test that. If you don't, like, I would take your calculator right now and put it in and see if you can get this answer. If you don't get that answer, you've done something wrong. All right. Last shape is this cone shape here. Okay, this cone, again, the circle part is easy to figure out. It's just the same as anything else we did. Okay, that part is just the pi r squared. Okay, but then we need to figure out how do you find the surface area of this cone shape here. Okay, just use your calculator. There is a way of doing it, or sorry, your formula sheet and then your calculator. It's a, it's kind of like you're again taking a flat piece of paper and it's being like rolled up into that cone shape. Okay, not quite a cylinder, but it's like coming to a point now. But there is a, mathematical way of figuring out what that is. And so it is this part here. Okay, the pi r squared on your formula sheet, this is what's the bottom circle. Okay, pi r squared is the exact same as the area of a circle. This part is talking about what's the area of this pointy top outside part. So be careful that the radius is easy. That's the same as it is for the bottom circle. But this S is easy to mistake. This S is talking about the slant height. It's not talking about the straight up height up and down. Okay, that would just be the height. That would be like H. Okay, S is talking about the slant height, which is the diagonal edge going down from the top to the bottom like this. So just be careful that you don't put in the straight up and down height, that you put in the slant height. Other than that, it is, exactly, it is just plugging in your numbers here. So right. All right, now you'll have to excuse this diagram. It doesn't actually give the slant height. It gives just the normal height here saying 11. There is a way to calculate this based on what we do in later in the course, but for now I'm just going to give you the number. So the slant height here is supposed to be 11.4. That's how long this edge would be. In the other questions, like in the practice problems, it will tell you what the slant height is. So our surface area is equal to pi r squared. So pi is pi. R is our radius, which is 3 squared. I'm just going to put this in brackets to show we're multiplying. Plus pi times r, our radius, which is still just 3, times our slant height, okay, which is our 11.4. 11.4. Okay, so you're going to put this all into your calculator to get your final answer. And that's it for this question. All right, so you'll get a final answer as long as you put everything into your calculator right of 135.7 units of centimeter squared. You might have your answer is like just slightly lower or higher than this. If you use like 3.14 on your calculator for pi instead of actually pushing the pi button, it'll just kind of round things slightly differently. That's not a big deal as long as your answer is like very close to, like, if it's 135, 136, that kind of thing, then you're fine. If it's not even close, or if it's like 100 or 200 or something, then you're definitely not on the right track. You need to check how you did this in your calculator. So you'll notice that in the practice problems for this, that the answers are here. Those are the correct answers. The point here is that you need to, for this, you have to show your work. Okay, so on these ones, the point is not writing down the correct answer and having a blank sheet here. Okay, this one you really need to think about what are all the surface areas that you're finding, and then add them together to get your final answer. And if it matches here, you've done it right. Okay, these are here to make sure that you see right away whether or not you've made a mistake or not. So other than that, good luck on these. They can take a little while. These ones actually aren't too bad. These are more simple shapes. The next ones are a bit longer, but yeah, if you get practice at these, it'll be smooth sailing. Good luck.